Hi, good evening everyone, and welcome to the fourth session of School of AR. Today we'll be learning about skeleton animation, and we are hi, good evening everyone, and welcome to the fourth session of School of AR. Today we'll be learning about skeleton animation, and we are Naveen, can you
Hi,
mute the
good evening everyone. Welcome to the fourth session School of AI. Today we'll be learning about skeleton animation and we are
Naveen, can you
Sorry, yep. Okay, thank you. I was some sort of like echo to me. Like, okay. Thank you, Asghar. Thank you so much, and good evening, everyone. We're ready for our fourth session today. I hope you're clear until now. If you have any questions, I'm gonna take a few minutes to answer any left out, any questions that you're struggling with from the earlier concepts, and meanwhile wait for everybody to join. There was a question which was asked the last session, and we were did not have enough time to address that. This was about the depth buffer and write to depth settings, and we will cover that today as a part of our today's tutorial as well. And I noticed a few things when I attended the session yesterday, that there are some things with at the bottom of the screen you can't really see here. My screen is not shared yet. Wait. All right, so I understand that if this part probably be blocked by some UI elements, probably my face. So I will try to cover not. I will try to minimize the project and show you if I click here, like where I'm clicking. And the top part is also yeah, we have Reskill and Spark here logo here. So let me know if you can't see something in the comments, if something is not visible, but I'll take care that it's visible for you. Okay. If let me, I'm just gonna take a look at the questions and then.
or else what I can do is once you start the session, I can make your screen full screen like this, if that's okay.
Yeah, we can do that, but today we have like a 3D effect, and we are not using a my camera texture there. So it's better to make it visible there. It's very small screen at the bottom. We don't have many things here at the bottom of the screen. We have a few things here, but so it's better to keep the video feed there in the left bottom.
Sure.
Yeah. Because sometimes I try to make my hand gestures and
Yeah.
show near and far objects, so that's convenient. Shikhar, I got your question and I reply to you. Well, I did not have enough time, and I'll get back to you. Do not worry about it. Be patient with me when so that I can get back to you on time. Yeah, it's a good suggestion. If we can do that, Asghar, we can move it to right bottom.
So that's not an option here. It's only at the bottom left, or I can hide it,
Sorry, Ankit. It's gonna be in the
or
left.
it's also this way.
Okay. Neha, we are going to use just Spark AR and no other software today. Whatever we are doing, we will try to be as much as in Spark AR, so that you use it for even your smaller thing. You create textures here, so we'll do everything in Spark AR. And hi Sahil, hi Rain, welcome to the session. And okay, I'm going to start with a quick introduction. Well, today we're going to talk about skeleton animation, and how do we proceed with the session is that we have to follow the steps that we do, or probably look first and understand the concept why we are doing it, And then quickly, whenever you get like a, when I'm trying to repeat something and you understood something, you apply it in the background in your Spark here. Open. I hope you keep updating your Spark here. So right now, I'm going to share a link that Asghar going to share in a while, and that link has um, some basic setup that you can follow, and you go to this Spark School folder, and there's a session 4 folder here. All you have to do is go there. I'm gonna share this link, and Asghar will share it right away. This will only open the project will only open in version 137. So if you have version 36, it's not going to open in that. So you have to download the latest version to apply these. I'm going to also teach you how to manage the Spark Air versions in the session. Maybe let me do it right now. So if you're downloading it's going to help you. You see that I have so many versions installed in my Spark Air. Like in my laptop, I have 27, 29, 130, 130, 25, and I can use all of them. Sometimes I have some specific project that I worked on, let's say 135, and we don't want to upgrade to 136. I just want to stay in 135. They have slight difference when I talk about versions, like maybe certain capabilities, like maybe 127 would not have like a depth textures, or maybe prior to these maybe won't have hand tracking. So these new capabilities are introduced in the new versions, like it's getting better every day. So I have 136 right now, which was older. I was using this until yesterday. Today I'm using this one. This is latest. So whatever is the latest, I don't change it. I just call it Spark Air Studio. And whenever there's a new version out, I download it, and before installing, I change this name to, let's say, this was my 137. Now, if I install a new software, it's gonna be Spark Air Studio and nothing in the end. So this will be like a separate installation for your current version. Right now we are at 137, so that's no problem. You can download from the website. Just download now. If you go to the website, and then the first link that you get would be the latest version, like from the Sparker website. Okay, so what is a skeleton? What do you mean by a skeleton? Like, I think the clear image that comes to my mind is like a skeleton of a man. That's what I understand. Um, so correct, that's correct, but that's not the only skeleton. Everything can have skeleton. If my this just I talk about my hand, there's a skeleton which supports my hand to move it from the joints. Like if I move my finger from this joint, I can move it like this. If I want to move my finger from the middle point, I can move it like this. Similarly, like if this is the neck point, my neck can come down and can go in the back, can go in the right, can go in the left, while my none of the other joints move. So these joints are responsible to give you a hinge point. Around that, you can kind of make moves, in the scene. And everything can have these bones. Like this little structure is called a bone. From here to here, this is one bone, this is another bone, this is one another bone, another bone, another bone. So these are like bones. They can have certain scale, can be lengthier, can be smaller. The main point is this, the hinge point. And mostly we work with the rotation of these bones, so that if I rotate this, I can rotate the entire. Like if I rotate this, I can rotate this entire whatever is in the down here, if they are parented under this. So they will also learn this. But just to understand what is skeleton and what is bones, I hope this is super clear. And I'm gonna just jump into the finished project. Have we already downloaded the unfinished project? It looks like this. Okay. Let me tell you the expectations today. What are we gonna make? This is a teddy bear. and we're gonna call it a puppet, and we're gonna make this puppet dance. We're gonna make this puppet move like this. So if you go into the details, I can see that this puppet has certain properties, like it is kind of stuck on a spring. It has got hands, it has got a mouth, eyes, and ears, and everything. It is wearing a cap. There's a number on it. And if I turn on my. Oh, okay, if I'm moving my head, it also moves with my head. If I blink my eyes, it also blink the eyes. And yeah, it's pretty interesting. Oh, if I open my mouth, it also opens his mouth. So these all things are connected to my facial movements. So we're gonna deal with them one by one. But you understand the properties. We understand the main goal where we're gonna reach. So let's jump into the blank project. Where in the blank project, so here we have like all the connections and everything, like what is to be done after we learn this. But in the blank project, we just import the 3D model and nothing else. We just import the 3D model or maybe some textures that we can apply, but rest of the things we don't need. So I'm going to go to the unfinished project, which is just to give us a jump start. If you notice that there are a lot of things which are not here right now, this it's not moving, it is not reactive to my movements. There's nothing, it's just a teddy bear that we have here. And how this opens for the first time, let me show you. All right, so I'm gonna delete this teddy from here so that we can start fresh. This rectangle as well, you can delete it. So we are starting fresh. We have a Teddy 3D model imported into project, and there are some textures which actually come with the 3D model, so don't have to worry about it. And there's audio and texture animation, and we have covered these, so I'm not going to repeat these every day. But it's just like importing importing assets from your library, from this library if you want. There's a library here as well. Like if you click on it, where it is. So if you click on this plus button, it pops up a library where you can import 3D objects and sounds, and even you can create your own sounds and import it here. Now, this is empty. There's a null object. I don't want it. Now I'm going to go to the focal distance, and I don't want to see my background, or actually it's better so that you can get a feedback. In the project, we don't need it. So we're going to use a canvas, and canvas to have a 2D textures on the screen. And I'm going to use a rectangle in it, and I'm going to call it background, because this is going to be in the background. And this is right now just a checkered box, which is very small. And I'm going to make it 100% in X and 100% in Y. When you make it fixed, that means that no matter how much you're going to move, like you can resize your window. And if I resize my window, I'll notice that, like for an example, like if this is an iPad, so I told it to 100 and 100, and it is fixed. Then if my device changes, this is going to be fixed. So this is something we don't want. Like that's not going to fit. Like if you see my camera texture is fitting to um, it's fitting to the screen size of my simulator. So I'm gonna do is that I'm gonna make it relative. Relative, that means it's gonna fix to the length of the it's gonna fix to the length of the screen, like the width of the screen, and also gonna fill height, and it becomes relative. So it's relatively bigger, relatively in width, and relatively in height. I'm going to just go to my iOS like the simulator. You can simulate to be like an Android device or whatever device you want to work with. Usually when we work, I work with iPhone 8, which is not here anymore. But okay, I think this is a new update. They've kind of removed iPhone 8. Looks like iPhone SE only, so maybe they discontinued it. That's why newer versions now. So iPhone SE, I'm gonna work with. The background has no textures right now. It's just a checkered box, and I'm going to make it. I'm going to give it a new material, and it's gonna call it matte background. Actually, I have a habit of giving an underscore in the middle, so like I know that this is a material and this is responding to the background. And right now it's a standard. We usually don't care about the lightings. If you don't care about the lightings, then for the 2D object, then just go with the flat material. It becomes super white after that. And the texture is white. If I choose the opacity, I can make it like whatever opaque you want. um, how much you want to cover. So opacity we all understand, very easy term. But I don't want it super white. I want to have like some random city into it. So I'm gonna create a consumer patch to this, and I'm gonna say that um, give me a gradient. Like don't make it entirely white. Give me like a pattern where something is grayish somewhere, something is whitish somewhere, something is like black somewhere. So there's a gradient patch in the patch library, and if you import this gradient, you will notice that it comes with like a three settings. Right? Do you want the gradient to be horizontal? And gradient is just texture which goes from like let's say 0 to 1. So it's gonna be like white, 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 white. Like it's gonna be like black at the start, and then and white here, black and white. At 0 you're black, at 1 you're white, and in the middle this is the transition how black goes to the white. So this is a gradient, like okay. And if you see like if you see this, wherever I have black, I can see my camera texture in the back, and this is white. So it's kind of like starts from white, fades out the white, and starts the black, fading in black, and makes it completely black, right? So we get this sort of gradient like this. And if you make it horizontal, if you make it vertical, then it's going to be like in this sense, in this manner. If you make it circular, then it's going to be like circular manner. It is black in the middle, but white on the circle. So we're going to use horizontal at the moment. And another thing to do is that this is not actually what I want, but we understood the gradient. We're going to use this gradient, and there's a gradient step patch. It is just to control how much gradient do we want and what is the color that we want to give, because right now it all became super the camera texture. I can see the camera texture right now, and I don't want it. I don't want the camera texture to be visible here. So this is going to be the output, and this is going to be the gradient. So understand the difference between these shader underpass to quickly see what this means. um, So this is transparent here, and this is white. Transparent because there's no texture. And if I do the same thing to this output, it's gonna give me black. It's gonna give me a color because we are kind of multiplying the previous step and to the new color. Okay, so we know that wherever I'm having my camera texture, that was black because of the gradient. If I give this output, like if this I give this output here, it's going to be black now. Okay, I'm going to delete this, keep it here because we're going to make some further changes to. And although we're going to see the output right in the simulator, but still we're going to keep it here so that you can make it a practice to see what this particular patch, until what this arrangement is giving you an output. And then like if you have certain steps that you have to follow, then at particular step how the texture is looking. Then I see that there's a start range and there's an and range. So start range, what is the start range? Start range, like where are you starting from? Like I'm starting from 0 and then I'm going to 1. So what if I want to start from 0.2? Okay, you can start from 0.2. So what it did, that this is my 0.2, this is my 0.2. That's where I'm going to start fading in now. And before that, everything is going to be my previous step, which is in this case is black. And if I want to start from point 0.5, then I'm going to start in the middle. My gradient is going to start from the middle and then going to be distributed in the rest of the space, like 0 to 1. Earlier I was from here to here 0 to 1. Now I'm here to here 0 to 1. So this entire becomes black. So I'm going to start from 0 only. What I want is I don't want this black thing here. So I'm going to increase this a bit to so that there's not too much white. Actually, let's not have white and have black so that our teddy bear is visible better. Maybe lesser than this, or also can try to have a vertical. Vertical looks better, much better. Turns out to be a good value. You can work with it. You can add more things. You can add more colors. Let me teach you that. Like if you're talking about gradient steps, then let me teach you that as well. So I just use one gradient patch and I change this to like okay from 0 to 0.5. Give me this. I'm done. This is what I wanted. I'm done with it. But I'm gonna change few more colors. Like what if I want multiple colors? So instead of this black color, give me a color which is this color. Okay, so that became that, and this white becomes like this color. So there's a mixture of these colors here. I can see, right? There's a mixture of these colors, but this is from 0 to start, and I want to end it at point 3, which is so I'm a vertical gradient right now. So I starting from 0, I ended the the transition at 0.3, and after that the pink is repeating until the end. So my gradient is ending at 0.3. After that it's a solid color. It's not a gradient. And then I'm gonna copy this again and use this gradient in the gradient patch input. Like that's what we were doing. This gave us a gradient that we modified. Then this gave us a gradient, and we're gonna modify it again and take this to as an output because we don't want gradient, we want the output. Now we want the colors. My previous step was can be the color that is coming out of it, and my new color can be a new random color, like maybe this color. And until point 3 I've done. I want to go until point 1, and I'm going to start from point 33, actually make it point 33 as well, and go to 1. Now you see that until here, point 3, I'm actually working with two colors, this yellow color and this pink color. After that, from point 3 to point 1, which is point 3 to point 1, I'm mixing these two colors, the output of this with the blue color. If I go 0.66, I just gonna stop here and the rest is blue. Then if I want another, then I can do that as well. I can take this gradient, put it here, and take this output and start from 0.66 and take my new color as a what color can we go for? Purple, not bad, and go until end. And I can see that I don't have the output here, but I have the output now. Is that I think it's super clear now. So we can have those colors like this, but this is actually your imagination how you want to do it, but you should know the concept. Once you know the concept, you can do anything um, according to your imagination. I'm going to remove these, don't need them, so I'm going to remove these. Just going to add a gradient step because I don't want many changes. I just want to make my background a little bit darker and not too dark. So look strange. A little bit dark and it has a little bit white, but more dark into the scene. So take this output, make it to 2 or 2.5. So it's on towards the darker side. All right. And okay, I'm done with my background. My background is ready for me, and I can have my teddy bear. So the only thing that renders in the scene right now is the background. Now, where do I want my teddy bear to be? My teddy bear should be in front of the background, of course. So the rendering order in the scene hierarchy goes top to bottom, right? So I'm going to take this and place it here. Okay. And I see that when I import it, it's kind of it's kind of very big. It's super big that I can't even see it in the screen. It's going above my camera like that. So I'm going to make it smaller, maybe zero point 0.5, zero point 0.5, and zero point 0.5, and reposition it in a way. Okay, I'm not gonna change this 111. I'm going to create a null object and keep it inside so that we keep the original size of our 3D model, but we can modify the parent of this. So I'm going to call it like a placer or um, teddy holder, like it's just holding the teddy, it's doing nothing. And then I'm going to decrease this to 0.5 and 0.5 and 0.5. And I'm going to, these are the manipulators, you can click on these and manipulate these things. So I'm going to make it a bit lower so that I can see it. I can see it now pretty clear. So it's a good, all right. Now you see that, notice this is my screen and this is my box. This is my teddy, and it is bigger in the Z direction. So some of the objects are going behind it and some of the objects are in front of it. And then I have my gradient. And that is where the concept of depth buffer and depth, right to depth test comes into the picture. Like, what should we do? How do you want to handle this? Do you want to show the back, the whatever goes in the back? Like, of course, we need to tell Spark that how do you want to treat this depth. If you want that background to be forever in the background, it shouldn't matter that my some of my 3D model is going in the back. Then the background should always be rendering in the back. So I should always be able to see this flap which is in the background. So we will change that. Right now I can't see that flap. So what I'm going to do, I'm going to go to the material of this background. To go to the material of something that you want to change, there are two ways. Either you remember the material, like, okay, matte background, I just made it, so I can just go directly, or you can click in the scene, and I know that I want to change the background settings, and I can click on the material here and double click it, and then you can be in the background panel directly. And I go to the advanced render options and I change some settings here. Now, if you want to use the depth test, that means that it's going to matter what is near and what is far. But if you write to the depth buffer, okay, then of course we disable this. If you write to the depth buffer, that means you are careful about the near and far object. And if I do this, then like I don't want to write to the depth buffer. That means that I'm not even passing my depth data, like the how much are you in the depth, not depth data, that would be a wrong term to say, but near and far data, like how near and how far it is. It shouldn't matter. So that means my background can always render in the back, even its position is here and these things are in the back, but it will always, I chose to render it in the back. Like, okay, so it will always be my background. So imagine that the sun is so big that if you stand in front of it, that it will always be your background. You cannot ever go behind it because it's super big, right? So just a poor example of that, but understand that, like, it should render. The render is the right term, but let's stay technical. So it should render always in the back. So right now, since my settings are that I'm not even caring about my depth, it's always going to in the back. It's always going to be in the back. If I also disable this depth test, then it's going to take the render order from here, show you teddy first and then show you the background. If I change this order, then you will not be able to see the teddy, because right now we're not caring about the depth data, we're not writing the depth buffer, and then we're going with the scene hierarchy, and you're telling that please render the rectangle first and then render everything behind, then nothing's gonna show you. It's gonna come because the depth. If you check this, then probably you'll see something. If you check this, like okay, use the depth data. If something is in front of me, then show this. But it won't show you.
Could you say that again? My apologies. I couldn't hear what you said.
Okay, so this is done. I'm gonna change these changes again quickly, make this steady back here, and this we can use, but we don't want to use this because if you use this, then whatever is in the back, we won't be able to see, right? Okay, so don't want the depth buffer data here. We're done with the first steps. Any doubts, anything here? Write it, please. I see that all is cool. Okay. Have you opened the project? Have you found the link? Where are we in terms of progress? Okay. Teddy bear is ready now. The teddy bear. Let's open this teddy bear. What does it have inside? So this teddy bear, it has a like a this entire mesh centered at the bottom of this, and now we also have skeleton, which is the shows that let's see what is inside. There's a model group uh, which probably have some certain combination of the meshes. These meshes has like a, if you see his the grayed out, there are like some bones inside, like 1, 2, 3, 4, 5, 6, 7, 8. Some bones are, I can see them, but they're not visible here. But they're visible here. There are some bones I can work around, and I can if I go into the model group, then I can see that there's a outfit group where I can see there's a shirt, there's a hat, and this shirt and hat can be, if I make it visible, make it not visible, so I can like control these things one by one. It's like a combination of certain arrangement, certain clothes, certain fingers, hands, and to make it like a teddy bear. There's a spring as well. So we obviously we disable it. It's just to test like how, there's a hat as well. You can um, check the visibility or not. The sleeve. So not useful at the moment, just to go through it. And then we have eyebrows. So possibly if you want to like do something with the eyebrows, we'll come here, and there's a mouth, so we can control this mouth somehow. So that's what we're going to talk about. We're going to use. So it's very important that you go through each you go through the 3D model and see that what are the things that I can use to animate it. What is my end goal? And once you understand that, like it gives you like a roadmap. Like okay, I want to move the eyes, so I need to know where are the eyes. So I found the eyes. There's left eye, there's the right eye. So I can, oh, there are eyebrows as well. So we can, if I move my eyebrows, I can also change them. This is the entire head, so I can like make it rotate or something like this. So this is a box as well. If you want to rotate the box, spring, of course. So these are the meshes. Okay, these are not the bones. You see this icon here. This icon is for mesh. Okay, this is not the bones. So this is one. We were into the teddy group just now. Sorry, we were in the model group just now. Now there's a skeleton root also, which is centered here. And if I go inside, I can see that this is the bone icon. You see that Sahil, I did not create the 3D object. This object is probably somewhere in the library, and I'm actually not a designer. I am a developer, but it's not very hard if you just follow some YouTube tutorials how to design a 3D model. Probably I think for you already come from a web, like a software background. I think within 2 or 3 hours you'll create your own teddy bear. So these things are like need to know basis, like creating your own 3D model, and you don't need like everything, like what does this mean. You don't need all the knowledge of the tool. You can just Google it how to, design a simple 3D model in Blender. So Blender is the tool that you want to go for. It's a free, it's open source, and just need to know basis that what you need for this. Like, okay, how to rig, how to animate, how to assign bones into a 3D model. So probably that search will give you a right tutorial, and you can follow that for like 30 or minutes or an hour, and you will be having some results. Okay, and then with practice, of course, you can make this better. So right now, for learning purpose, just try to import all 3D objects which are already there in the library, or yeah, just use the library. It's convenient. It's right here. You click it and import it. So for learning purpose, it's fine. For your projects, then you're free to take them from anywhere. You can hire a designer, 3D designer. You can get it from online and pay it. You can get some free models as well. You can get some free from Sketch. So that is up to you. Now, if I go to this skeleton root, this is the bone icon in front of it. And I can see that this is the root bone, and there's another bone, and this another bone. So I can see that this could be right outside, like in series, but they're inside. Like this is the parent, then this is child, and this is again the child. And so basically, this spring mid is parent to jack base. The skeleton root is parent to both, because parent, like it is indented, right? It is not in the same hierarchy, like this canvas and this is the same hierarchy. But if I disable this guy, everything would be disabled, because they are parented to Teddy. If I disable this, everything will be disabled. But if I just disable, let's say, just one box geo, it is just gonna disable the box, because there's nothing parented. This is just an independent mesh. So now I want to tell you a very important concept. So I'm going to hide this. I'm going to make a plane. There's nothing in our scene. I'm going to make a plane, and this plane I'm gonna. So you see that whenever you make something, whenever you import a scene object, it is always centered in the center. Like it is always in the center. So if I try to make some operations, if I try to rotate it, it's gonna rotate along the center, right? It is rotating along the center. So that's note. Now take a note of this, because we're gonna learn something out of it. I'm going to squash it, make it like a point one. So and then also increase it into y, maybe make it 5, or maybe make it 2.5. Now I have this in the center. If I try to make any changes, it's gonna go around the center, okay? But I don't want to rotate it from the center. I want to rotate it from here, like rotate it, in a different way. So I'm gonna create another line just to show you that where do I want to create it. So just to make it like 90 degrees, and then manipulate it to go down. So this is my hinge point. This is my hinge point where I want to rotate it from. That means if I rotate this object, it's going to rotate from here. So I need a new object whose origin is here. Okay. Then I can, rotate it from this point. So how do I get my origin to here? So to do that, what I'm going to do is I'm going to create a null object inside it. I'm going to right click it. I'm going to create a null object. Pay attention to this step. It is very useful. And I'm going to call it a hinge point. And I'm going to move this hinge point to the place where I want my new center to be. Okay. And move it out of the hierarchy. So I wanted it inside the plane, like inside this, which object I wanted to rotate. Then I created my desired position, and I move it out of the scene. Like, okay. And now I see that this hinge point is already here, and this plane is, of course, the original position. And if I make it a child of it. So I did the like, what did I do? First, I created a null object inside the plane. Then I put set my position. Then I put it out, and then the parent is now a child. So if I take the hinge point now and I rotate it, I'm going. I'm so my rotate my hinge point has changed. It is not actually rotating around the center. Are we clear with this? This is pretty important concept. Very easy to understand, but still so much into detail that we could do a lot of things. This base was just to give you a like where do I want my hinge point to be, and then we could also do something like I don't want this here. I want this to be in here. Okay, like a joint at the corner. Then you can also do that. Just same steps. Take this plane, put it here. Okay, we gotta move the entire thing first. So we change it here, and then take this hinge point to the where you want the hinge point to be, and take it out of the hierarchy. Put this back to the hierarchy, and this is my hinge point. Now you can use the manipulator to rotate it from that hinge point. So why am I teaching you this? Why is it so important? Is because you need to look at the camera right now, and don't look at the camera. I'll appear here. So if this is my hand, and one bone, second bone, third bone. Okay, don't worry about these bones. So first bone, second bone, and third bone. This is my parent bone. If I move this, I can move my like these hands also. But this bone is not parented to this. If I move this, I cannot move my shoulder, right? I can only move these things. So this is why the parenting is important. Um, Go back to this, delete these examples, bringing back the teddy bear to the scene, and applying whatever we just learned, the skill and root, skeleton root. And if I try to rotate this, I can see that the entire thing is rotating. But my end goal is not to rotate it entirely. My end goal is to rotate just the box should stay right there. So I can see that my first joint is moving this entire thing. Let's go to the second joint, which is the spring joint. And if I move this, I can see that okay, that is good. That is better. I can rotate this. So this is good. Let's go further. There's a jack base. I think they're calling this teddy bear jack. So this is jack's base. If I rotate this now, the spring is affected, but only in the top part. Here, the spring was like kind of affected from the bottom, and here it is affected from the top part, like where it is actually connected to the teddy bear. Okay, let's see what jack base has. Jack base has got some things to do with the neck. That means that we can kind of rotate the neck right, left, up, like in front, and go also in the back. And then we have some things to do with the arms as well. I think if you see that these joints are for arm, and if I go to this one, don't move them. Don't move these joints. If you move these joints, you're gonna take the hand away. But of course, you can make something out of it also. Like let's say you wanna create a simulation where uh, what is this thing called, the assembly of the steady, the hand is coming from the right, hand is coming from the left. Like somebody asked about the Thanos disintegration effect, and then just imagine and create something whatever you want. You're hero of your own story. And I'm gonna control Z for now. We're just moving the rotation. We don't want to actually work with the position right now because teddy bear looks okay to me. I don't want to change any, like move it like a handicapped person. And if this is not the right rotation that we want, probably this is the rotation that we want from this joint. Like okay, this joint is gonna move. So understand this, that this joint is tied up to the mesh of the hand. So if I rotate the hash, if I rotate this joint, it's gonna move the mesh. it is not. So if I disable, let's say I don't have these skeletons, then it's not going to disable my meshes, because these are just bones that are not visible, but they are controlling the meshes. So um, what else we have? We have similarly to the right as well, and we have already gone to this neck thing, jack neck, and these are not parented. These are differently. You can individually move them. Like hand and neck can have like a separate rotation, separate manipulators. Um, Pretty much it. I think we can now straight start from applying the materials first. There are material that come with this objects only. Like sometimes they will come with it. So let's see where are our meshes. Our meshes are into the model group, and I can see the box geo is steady mat 0. Okay. Teddy mat 0 has a texture. Teddy mat 0 and Teddy mat 0 is a standard. No, this texture is Teddy mat. So I'm going to actually select Teddy mat to all of them, because this has like a UV mapped. Like if you see that there's a texture in here, and this texture has information like where the hands are and where the spring is, where the box texture is. The one texture is having all the information. So if I apply the same texture to all of these, they're gonna automatically go to the right place, because that's how they're designed. That's how they're designed in Blender. So this is something related to the design part. And important, of course, this is called UV mapping. You map the UVs. UV, we learned in last tutorial, that each texture coordinate is like the UV coordinates are the texture coordinates in the 2D hierarchy, the 2D scene. Okay, 2D coordinate space. We have applied that, and the face as well. I think the face is inside here, and we're gonna say this steady mat as well. And there's one more group where shirt, hat, and G. We'll change all of these. Don't worry about it. But for now, we are ready with the. What I did is I applied the teddy mat, which just has this texture applied to it, and then applied to all the meshes that I had. I had like these certain meshes, and all of these meshes has the same material. All right, which is teddy mat. Okay. Um, Uh, See a question that if I click the unfinished project, then I will redirect it to Spark AR Studio. Yes, sir. You will be redirected to Spark AR Studio. Make sure you have version 137. If you don't have, then it's not going to open. All right, let's do our first animation. How do we proceed? So for the first animation, let's try to move the spring. Let's try to make it like like a little jumble bumble, and then we'll make the hands move, or we'll make the eyes move, and then we'll also connect them to the facial interactions. Any questions, technical questions regarding the session so far? Please write them right now. If anything which is not clear, any doubts, let me know, and then we'll move in. Virendra, are you able to open the? What is the problem that you're facing? I don't know. Are you able to open it already? Go to this about Spark AR, and you will see that which version are you at. I am right now at version 37, and if you collect this skeleton animation unfinished project, just double click it, double click this .ar project file, and you will be redirected there. Okay, so meanwhile, yeah, Sandesh, that's a good question. So, depending on the movement of your, the kind of movement you want, like for example, the octopus. Octopus is like a very slurpy, very smoothly moved, like animal. Of course, that it can work like rigging can work. Like I can have where the tentacles are, like 8 tentacles, and then the kind of animation you have, you will need lot of bones, like because you want to have a curve. Like right now our bones are like straight hand, like that. But if you want to have a curve, then you'll probably need like smaller bones, bigger in a bigger tentacle. So like if you have like a maybe 10 bones to make it smooth, so if you have 8 tentacles, then you need 80 bones. And so many bones to manage them, you probably have to animate it outside also. Like if you do that in Spark, it will take a lot of time. Plus also it is not recommended to have more than 100 bones, although there's no such fixed number. But let's not have like more than 100 bones when you import a project, work with a 3D model with bones. So that's totally possible, Sandesh. Another way to do it as a weight painting. Weight painting is to for like smooth animations. They work well, so that you can also explore. Maybe after the session, you can search about weight painting to animation. So this is the rigging. What we are doing, this is rigging the any bones and everything. Weight painting is like you assign some colors to the part of the mesh, and then based on those colors, the animation happens. Like if it is darker, then more movement. If it is less opacity, if it is like light color, then less movement. Different color, different kind of animation, like that. So it's called weight painting. Like how much weight are you assigning to that animation, so that you can explore. It's such an interesting concept. All right, I'm gonna move ahead. Um, First, we decided that we're gonna change this spring. To make this spring move, I'm gonna not hide, but collapse these meshes because we don't need them. So the model and everything is in this, and this is my skeleton root, which I move. Then also moves the box, so I don't want to do that. But maybe I'll take this spring mid, which is just a spring. I'll take this, and I want to take this spring to move in the X. If you see that I'm changing this, there's a rotation is changing here. So this is my X axis, okay? And so this is my X axis, this is my Y axis. You can see this red is X, and this is Y, and this is Z. So anything which rotates around x-axis has to rotate like this. Okay. If anything has to rotate around y-axis, it has to rotate like this. Anything which goes to z will have to rotate like this. So to rotate it in okay. So let's say we have 0 rotation right now. But if you want to rotate by 50 degree, you see it coming out, coming in front. If you rotate by -50, it's going back. So we don't want that much. Like we don't want this puppet to go crazy. We want like, okay, move little, like give us like a good feeling, not just like going back and coming after a minute. So maybe 10 -10 is like a good number that we can play with, like, like this we can do again and again. So I'm gonna create a producer patch to the rotation of this producer patch so that I can modify it here. This producer patch, I'm gonna give it like a loop animation. Loop animation will produce a transition And this transition would be a three vector number, which will change the rotation of the spring midpoint joint. Okay. This is so I'm going to start with, where do I start with? I want to start with maybe 10, and in the X, and I want to check this, how this is working. It's working like this. It's going in the back and then suddenly coming off. That means I want to mirror it, like be smooth, man. So this is how it's working, and I'm gonna. We talked about the curves. The linear is like going in a very uniform, linearly. So I'm gonna make it sinusoidal in and out, so which is pretty smooth now. Also gonna reduce this to, right now it's happening in 1 second. So I want it to move faster. So I'm gonna change. I don't want to give it to 1 second to go from 10 to 0. I'm gonna give it a lesser time so that it moves faster. So I'm gonna give 25. It's pretty fast right now. Maybe zero point 0.5 also suits us. So this is like the spring is moving, and I can see the entire object moving with it. I'm actually done with the spring's bottom part. I'm gonna move to my jack base. Jack base is, if you see that this red, if you see this red here, this is the rotation that I'm gonna change. It is moving because it is child to the spring mid, so that is why it is moving right now. But we also want to give it like its own rotation. Okay, so to do that, I'm going to have another transition patch, and take this jack base to here, and maybe 0 0. Now maybe I want to do it like the side to side, so maybe z, maybe -15. And if that happens, it looks good. I'm gonna make it sinusoidal in and out. These are just settings, okay? Don't be overwhelmed by them. Maybe -15 to -15, 15 to 5 to, no, -5 to 5. Just you can choose your own values. I'm just experimenting with what is best. Maybe I'll give -10 to 10. Right now I can see that there's a certain movement into this. Cool. All right, the spring moves okay. Next is the jack neck. Now, jack neck is can uh, move your head, can move your neck. So I'm gonna like pause it and then show you that I can just move my neck here and there. So how to decide the values, like what is the right value for you, is that you pause the project so that you can easily check the manipulators. And if I check this z rotation, and I see that if I move it by minus by +8 to -8, it kind of gives me, like maybe 10 to 10. So that's how I decide the values, like okay, what is good, what is bad. And then I control Z, and then like make it like a 0 already. And I'm now going to take another loop animation. Okay, so understand this. Okay, what kind of steps that we were doing in the patches, because after a while we keep working, it becomes like a huge project. But we go step by step. It's never that difficult. I like to comment my things, like comment around, and this is how my background would design. So I can now move it to, like, okay, this is done, so I'm going to move it right here. And if I want to make changes, I can always come back. But just to see that, okay, what am I working on right now is that. So I've also managed to um, give it like a slight initial rotation. So this is my hinge rotation spring. All right, uh, hinge rotation. This I'm also gonna move it up so that we are now we have like now we're gonna work with this new loop animation. Use again the transition patch, and this time we're gonna work with the jack neck. Bring out this rotation patch, consumer patch, and we decided that we will not change the x or y, but we'll change the z from -10 to maybe 10, and yeah. Now you can see that our head is already moving. We can see that, and also it looks like the values as such. It looks like when it's going right, it's kind of following the head. Like when my spring is going there, then it's kind of like following that, right? Maybe it will follow if I put it to 1, so that it's like a little bit delayed. Cool. Just try in our values, whatever value fits. You can kind of use those values and make it like it even accurate, like that. I think my neck is also done. What is next in my scene that I can use to animate this? After the neck, there's not actually many things. But to should we move to the face interactions, or do we want to do something with the eyes? Let's go with the face interaction now. Like I want my head to actually follow the rotation from the face, and to do that, I already gave my neck a rotation. Like I only have this neck joint, and if I this neck joint is getting values from here, that means this input is busy. Now I can't. How do I give it like a? How do I make it follow my face? To do that, we need to have like a add patch. Like we will take some rotation from my head, and we will add it to the existing rotation that we have, and we'll add it to the jack neck because we only have one input to it. So now let's do that right away. Is this thing disturbing me? All right, so now we'll take this. First off, we need to have a face tracker. Once we have the face, we don't need the face mesh. We first face tracker is just to track the face and take this. You drag it out. This face, it's by default, and we have discussed this in previous sessions. The face finder will find a face number 0, and will give us some sort of position, scale, and rotation. We take this rotation value, and we will add it here. Now, if I move my head, to do that, I think I gotta make it a bit multiply it with the number so that like it should show me more rotation. Right now I can't see much. Multiply is just like make it bigger. Like if I move my head by 5 degrees, then this should increase by 3 by 15 degrees. Let me also make this material a little opaque so you can also see my head movement. And looks like that this is too much. We're gonna remove this for now, and also gonna remove this for now so that we can exactly see what's happening there. Okay, that is not working. That means I can't see these values outside from here. Face index is 0. Did you find the face? Why? Okay, switch to the back camera. No. Find a face. Why can't you see my face? All right, probably we'll use this guy. Somehow this face tracker seems to be malfunction, so we'll try to have it another way, like face tracker and face one, and we'll bring it back to our scene and take this 3D rotation. And I hope this time it works, because sometimes it just doesn't work. Okay, let's try to take head rotation instead of the face rotation, and we give the head rotation as a boolean not required. Anything related to head 2D. So this 2D space. No, this is forehead for not. Jake. Hmm. I don't see a reason why it's not getting the rotation and it's not working. Is this like a version problem or something? Let me try to just try it on a blank project. Why is this not working? So what I want to do is I take a face tracker and bring it out, use this rotation to rotate some of the things which are not in the face tracker. Yeah, so let's take a plane and add this rotation to this guy. This version 37 might be just broken because it's just latest release. I'm not sure why that's not working for us. This rotation should be passed and should be working. Okay. Probably there's a. Let's leave this rotation for now and work with this. We'll probably fix it. I think this is the more like a tool problem, I guess. This rotation should be working. Like this gives you a rotation. I'm not getting any values here. Like if you move your head, it should show you some values, but it's not the case. Okay, what we can do is we can try restarting a project. That sometimes help. So I'm gonna save it as skeleton practice, and this is a version 137 project. So we're gonna do it like this, and I'm gonna close this and open again. Sometimes that helps. And now I can see the values, magic. So yeah, like sometimes things don't work out, then you try to. It's a very technical, not technical, but in IT it works like it works like universal. Like if you have a problem, the IT department will always tell you, "Sir, have you tried rebooting your system?" That might work. So this did work. So we're gonna go back to our concepts where we were trying to add these two rotations, the rotation from the face and the rotation from the from our that we decided that we're gonna give, and this is, if you see that my head is following this, the head of this guy is following this, you know, tan, tan, tan. So This might be like a little intense value that's going to happen, like that's happening here, because we're multiplying it by 3. So maybe multiply it by 1 and see that as it is, like pass it as it is. Then yeah, it moves, but it moves quite less than I make my head move. So I'm going to make it to 1.5 and 1.5 and 1.5. Okay. And I see that this kind of like, if I move my head like this kind of comes down to a certain like I don't want to go too low. So how do I manage that? So I'm going to delete this. I'm going to give it here and give it like this. So you can also limit like which direction do we want to rotate our head. Right now I'm giving like all the rotation. So if you even go into X, or even if you go into Y, all the rotations are happening here. But I can totally control like what kind of rotation I want to give it. So if I say unpack and unpack to vector 3, of course, because this is a vector 3 rotation value, and only take Y, only take Z. Okay, and Z is somewhere around. Okay, so if I'm moving like this, I'm actually moving around my y-axis. So I'll take the y and pack it just in the y, not in 0 and x and z, and then add it. So instead of giving the x and z rotation, now I'm just giving y rotation. So if I do this, if I go with my head into the back, then it's not gonna go, because if we go in the back, we can't even like look at the teddy bear. So that's not useful. So we're just gonna give the y-axis rotation to it. Now that happened. Now we have the rotation. Now it is actually reacting to our head, and that is working. And our initial animation that we disabled was like this. So kind of we have made our puppet to move like with my head. If I look there, it also look there, and it is like following that. Now this is done. This is also done. um, just a bonus tip: if you feel like this movement is not smooth enough, you can make it smooth enough. There's this patch called exponential smoothing, and what it does is that it kind of delays delays things in manner like, 2 point uh, in the start, and like it reaches to the end point, it kind of reduces the things in exponentially. So creates a smoothness. It only takes one vector value. So if you want to do to everything, then you have to use three such patches. But right now we just have one y, so we can use it. More smoothing you have, more smooth it will become. If I have like 1,000, if I put 1,000, then you'll see that it's gonna move like slowly and late. My head will reach there, but it's gonna just follow a little later. So 200 is a good value for this right now. Make it like a very smooth transition. All right, this was just a bonus thing that you could do with your things. And I'm gonna remove this. This was my head. This is my face. And what I'm gonna do, I just create this. This face is output. This face output is input to many face interactions. Like, you wanna blink, you wanna open your mouth. So I'm gonna create a sender so that I can utilize it, because every time if I go from here, it's gonna make like a lot of bad patches. So the sender is I'm gonna call it face sender, and always get back to this face sender. Now we've been like going quite slow in the session, so I'm gonna like speed up the things, because these are just settings that you have to go through. But you should understand why we are doing and what we're doing. So most of the concepts have been covered, but this is more like a setting thing now. So I'm gonna create a comment group, and then we're gonna say it like a face rotation. Okay. And then put it right here, so that we know that what we have worked on, we have worked on these three things right now. We've changed the hint rotation background, and we've also did something face related thing. Now, next thing I want to do is I want to move the eyes, or open the mouth. Let's open the mouth. Okay. So if I go and open the mouth, I have to see like what kind of interaction do I have with my mouth. My mouth has a bone. Yeah, it has a bone. So that bone can move up or down. No, that's not gonna help. So maybe probably the rotation will help. If I move the, no, that's not gonna help. If I move like this, no, that's not gonna work. If I move it like this, probably that's not the, okay. So that, let's go to the where are our joints? So we go to the jack neck, and in the jack neck you'll see there's a mouth upper and there's a mouth lower. That means it has two joints here. I'm disabling this so that I can see clearly. There are two joints here. Okay, in this mouth section, this is mouth upper and mouth lower. So how can I imitate opening my mouth? Is that I can move one of the lip to the bottom, and one can stay stationary so that it can emit rotating. So if I take the lower one, that would be better, and take the lower one and rotate it. Okay, that is working. Right, take the lower one, and this is kind of working. So if I'm at, this is like a closed mouth about 0, and then if I go about 5, 10, 10 is a lot. This is good value, like maybe we'll go to 6 or 7. All right. So how should this guy open his mouth is when we open our mouth. So mouth is a face of part of our face. So we'll take that input, like we'll create a receiver from the face center that we created. You could directly also do this. You could also do this, like take this and then create whatever interaction that you want. But since we have created that sender, we'll always convenient with the receiver. And then I'm going to go with the mouth open. There's a mouth open patch, and this mouth open patch gives me two outputs. Takes an input from the face, like which face, which mouth are you talking about, and then it talks about like open state. Is my mouth open or is it closed? So if my mouth is open, it's my mouth is open, it's just gonna give me a boolean that okay, your mouth is open, and this is gonna give me an openness, like how open is it? What is wrong with this face tracker? It's not giving me values again. Okay, yeah, you can see that if I open my mouth, it shows me some value like how open your mouth is. So this openness I can use to interact this openness with the, this openness can be either 0 or 1, like between 0 to 1. If your mouth is open a little bit, then closer to like 0, and like that. If it is wider open, then probably closer to 1, like right now 3. And then I think so we will use this value. And but why this guy is not working? Now it's working. Cool. um, we want to use the mouth's rotation, and rotation in what sense? The x rotation. So we need a pack before it, because we need to pack it to the 3 vector, and this is giving us 1 vector, and then we'll pack it and we'll give it here. uh, this value goes to 0 to 1, and the value that we decided was about 5 degrees to the maximum. So we will use to multiply it by maybe 5, and then we'll give it to the x here. So if I Oh, this is a maximum. We gotta go with multiply. Okay, so multiply is gonna go here, and we'll go just 5. I see that it is still less. The maximum reaching is 2 or like something. So I'm gonna give it 10. Now I see that I can open. I'm gonna give it 15. Now it's very easy. I'm gonna go to 20. Yep, now it's working. So that is working. Also gonna give it to a bit of exponential smoothing, so that it's gonna make a smoother movements. Maybe 100 is enough. Yep. This is my mouth. This is my mouth is moving based on the interactions that I just gave it. Now next thing I'm gonna comment it again. You don't have to comment everything into like separately. You can comment like whatever, like let's say facial interaction altogether. But here like we're going step by step, so better to like mouth logic here. Now let's do something with the eyes. And the eyes are, where are the eyes? I can see that there is a joint in the eyes as well. So this is called eye left and eye right. And what I do with this, if I rotate them, do I want to rotate them? I don't want to rotate them. I want to like make them make them go away when I blink. When I blink, they should be like not visible, right? So I need to add probably the scale property, I think, for these. So if I have the scale to like 0.1, they're gonna be like a smaller, 0.5 to like a smaller, but I'm gonna change all the three scale like with common values. Again, I'm going to use a receiver, which is face receiver, and there's a called eyelid, because this is eye related thing. And in eye relate, there's this left openness and right openness values, which is similar to the how mouth was opening and closing, and similarly that how big or wide how wide our eyes are opened. So we're going to use that property to do that. This left openness should give me a scale. Okay, so I'm gonna pack it. Right now I've paused everything. Okay, this is like a play and pause button. So when I try to modify some things, I tend to pause it so that I can find out the values and then see how they're looking. So left openness should be pegged in all the axes. Like this value should, I'm going to take a value patch. So this should be packed in all the axes, and then I'm going to give this to here. And you'll see that since I've given this to the left eye, I can see the changes in the left eye. All right, so that's looks like this. You can see it's following my eyes thing. Now you can kind of try to give the left eye to left eye and right eye to right eye, but like there might be a little bit of, these are machines, there might be a little bit of tendency where you speak or when you do something, the right eye is bigger and low is bigger, because we are expressive, it's not this steady, so it's going to look weird if one is smaller and one is bigger. So whatever I'm going to do is I'm going to use the same scale, um, same openness factor of the left eye and give it to here. You could do that with the right eye also. You just have to copy it and make it like this, right openness, and you can give it like this. But this is not kind of like a best practice that I would go for. Like you can see the eyes, there's a little bit of difference, so I'll just use the same thing so that they are not different in size, like that. Interesting. Also here also you can use an exponential smoothing patch. um, Give it like a 200 smoothing, and also if you like you can multiply, because right now the maximum is going is 1.7. Oh no, 1 also goes like so. Yeah, it's good. It's good. It's a good scale. So the eye is done. I'm gonna comment it to the eye. This is my eye, and that's done. What's left now? Eyebrows. There's eyebrows as well. So bro R and bro L and bro R. Okay. So how do I move them? How do I move them? To move these guys, I think I can use position because they're just moving up and down. You know. So I think I can use their position and change the position into the y direction. So if I take the manipulators and if I see that, yeah, that will probably work. So I'll take the position of these both left and right to create a consumer patch, and left and right both patches, and they have certain values with them already. So we're going to make sure that these values don't change, and whatever interaction that we do, we give them a new value and add the old values. All right. um, what can be the new values is new values is based on the your eyebrow movement. That means what was the lid having anything with to do with the brows? Nope. So we're gonna have another receiver which is giving us the face sender, and I'm gonna take the eyebrow patch with us, and this eyebrow has a inside and left top. I think the position. Yep, there's a position with it. The position is giving to us. So we'll take the center left inside end. So this eyebrow is left inside end. This is outside end, and this is top end. So we're gonna take the top end from the left and unpack it. Okay, and take the movement in y, take the movement in y, and that's what going to change things for us. Okay, so the initial values that we have, let's write them down. We add a patch and we make it like a 3 vector by just clicking here, and use the existing values in the top panel. So we make sure that, okay, whatever you had, you will have it. Your initial position will be intact. But if my user make any changes in the y direction, then I'm gonna change that offset and give you that position. And seems like that's a lot of movement. So I'm gonna tone it down. I'm gonna divide it by 5 and see how that works. I see that the bro is moving a little bit, but it's not too much. So I think I divided it by too much. Probably would have to divide it by 3. How's that the initial position is changed too much? These are correct values, and when I do this, this is kind of moves it a lot. So I think I'm gonna divide. Before dividing, I'm gonna subtract it, subtract the original value to, because right now it's going way up, and I don't want that to go that up. So I'm gonna subtract whatever I'm getting from here, subtract it to position it much better. So if I subtract it by zero point 0.1, that's going up. I'm gonna subtract it by minus 0.1. It's coming down, coming down, coming down, 0.05. Seems about right. This seems about right. Yeah. And then I can, yeah, I think this is the best. This is what we wanted. And also can add exponential smoothing again to just to smooth it out. This is not an important patch, but does add an additional detail to your filter. You see that so smooth movement right now. I think I can move it a little more, like zero point 0.6, too much, maybe 0.55. Yep, perfect. Similarly, similar things I'm gonna do with my right patch. So whatever operations I applied, I'm gonna take these operations. Actually, just have to take this operation. Like these things gonna be the same, right? For both of the eyes. No, 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 no. It's not gonna be the same. It's okay because this is left and this is right. So we're gonna take the entire combination that we made it for the left one, and I'm gonna paste it down, and this will have input from the right top, and this right top will go to here. But this addition values here will be different. This is minus 0.32 because this is like a, this was right and this was left. So from the middle there was 0.32 here, and this was from the middle minus 32, and rest of the things are the same. And we're gonna check this now. Both of my, you can see that both of my eyebrows are working. You can see that if I am moving my, let me show you. If I'm moving my eyebrows, if I'm moving my eyebrows, they're moving as well. Okay, now that is done. What else we can do? What else we can do? We can also make the hands move. Nose is done. We have already learned how to add audios, but even if like you want to use the this audio in the background, very simple way to do it, to add a playback controller and add an audio playback controller, which is very simple. Like we created a playback controller which gonna play an audio. Give it, tell it to. So first step, add a asset which is in playback controller, audio playback controller. Give this an audio, which audio you want to play, which is this scale element animation, and we want to play it, of course, and we want to play it on loop. That is shouldn't stop. And we need a speaker to listen to this. There's no speaker right now, so we create a speaker from here, and the speaker should have the output from the audio playback control we created. And as soon as you assign that, you can see that it's working. And right now I'm just gonna disable it because it's gonna keep playing. So just very simple thing that we did just now. What else? What else? What kind of animation do you want to move the ear? But we don't have a bone there. But you could do probably. But we don't have like, we can't move our ears also. So Teddy can do that, not us. Hand could have an interaction with the hands, but that is a different class altogether. Hand tracking is, we're gonna cover that first, and we'll probably can use that. But you'll feel free to add your own interactions. Like let's say if you make a kiss face, or if you make a, like if you make a blink, then something should happen. So you're free to create your own animations, right? What else? I think most of the animations are super done, but I see that there's an animation which comes with the model as well. Let's try to apply this. Let's try to apply how does that look. So we go to the add assets and playback controller, animation playback controller, because right now we're playing animation, and the animation clip is our dance clip, and which should be applied to this guy. Okay, I think we cannot use the animation because we have created our own animation. We have kind of modified these wings, like these things. But to do that, I'm gonna save this. I think this is pretty much done. We're done with the project today. We're done with the all the assignments and everything. You have doubts, let me know. Like, but I'm gonna show you the animation also, like how that works. So I'm gonna create an unfinished project which looks like this, and I can see that there's an animation clip here, and I create a playback controller which is an animation playback controller, has a dance animation to it, and this dance animation, this playback controller should be assigned to the main mesh, which is here, and I assign it here. And you see that, okay, this is how it's moving. Um, so this is just, these animation are, if you notice, these animations are kind of changing these values, like the values which are like a jack base. If you see, the rotation is changing here. um, Yeah. So when these values are changing, this means that this dance animation has this animation clip. It has that data, like what to move at what point, like what, how much rotation, what to move. So these things are done outside Spark AR. Like this animation was created outside Spark AR, and we imported it, and this is very easy. Like everything is moving. We didn't have to make any changes. We didn't do anything here. It is automatically done by this dance animation. But we learned we learned how to do that by ourselves. If they have the bones, we could do some sort of slight animations, because these animations are costly. They take a lot of size when you create them outside. So this one animation probably would have created some sort of, you can see the asset summary. This is a very small animation, like 7 kbs, 1 kb, but this can be like a, because not many values right now, not many data, just like rotation and stuff. But if you have like a larger data, larger animations, these can go like a bigger size as well. You can see the asset summary, asset size here. These are helpful to kind of make sure that you stay under 4 MB, or whatever, if there's an increased limit in the future. Um, we almost did something like this. Additionally, we did not move the hands. We could do that as well. Um, that's not a typical part. Just a rotation of the hands by default, without any interaction. So I will take the arm animation, like where is this joint that I'm talking about? I take this joint. This joint is called arm R, and where is this? This is arm L, and this is arm R. Okay, so I'll take both of these things. Get familiar with the how they structure things, because it's important. Like, they created a neck, they created arms, and they created hands alongside them. So I'm going to take this arm L, and I'm going to take this arm R. And so first I want to identify, like, how do I move them. So if I move them in the Z, that's going to give me something. I can move by -10 to 10. That's a good number. And similarly, I can do that the same thing for the other hand. So I'll take the rotation for those values, I take it out, I make this consumer patch, and I see that right and left and here, and I'll just use a loop animation patch, and make a transition. And it's supposed to change the rotation that goes from -10 to 10, and that should be like this. You should mirror and do it in 0.25 seconds. Yeah, the hands are moving fine now. And we have disabled animation for other things. So let's enable them. Enable this animation, enable that animation. Is there any other animation? Yeah, so this is how this is moving. Let's refresh it to, we can, I think, make the hands better. Make it like a sinusoidal so that everything is pretty. Yep. Can make things intense on the spring part, where you just 10, can make it like 10 to -10, and then you'll see that's moving higher than earlier. Could also give 15 to this, maybe 5. And you can experiment those values, whatever suits best. Maybe 10 here, and can also adjust the time to make it like a more wobbly effect, so that like upper things move more, but the movement in the bottom is lesser. So the time I given to this guy is zero point 0.5, but a time that I given to this guy is 0.25. And also based on like how much movement you want with the that. I hope this is clear. Now we have these things. There's a patch called Teddy outfit in here. You can also change these outfits. So um, I don't actually prefer the patches which will give you the output directly. You can always give it a texture input and an animation clip, and it will give you an output. But let's try to do that by ourselves. Try to learn it like how these patches are working. But this patch can be found in the folder, and you'll just have to pass it and it will work. I want to change the texture of this shirt, white shirt right now. So possibly I'm done with my animations. I'm gonna like collapse it, go to the shirt, and the shirt has like a white material right now. So I'll go to the teddy mat, and I'll take out the texture, and this texture is here. Or you could directly change the color from here, like if just the color. Okay, no, it's going to change the entire thing. So the first thing that we need to do is delete this. We're gonna go to the shirt and assign a new material to it. Like right now, the teddy mat is common to like a lot of things. So if we make changes to the teddy mat, it's gonna make changes to everything. So we're gonna create a new material, and we're gonna call it um, mat teddy shirt, which is a flat. And now if I change the color to this shirt, it will have different colors. If you want to show numbers on it, you could show numbers on it. If you want to like show somebody's face, you can show somebody's face here. um, so yeah, that's one thing. Similarly, you can change colors of everything. So what I'm gonna do is I'm gonna keep the texture that it has. It's like it's a little bit matte texture. If you notice, like my box and my this hand is like a matte texture. When I made it flat, that is gone. So basically that was coming because of this texture. So I'm gonna keep this texture to a teddy shirt, and probably change the colors of the shirt, right? Like maybe have a different color. Now you see that the texture is still there, those lines are still here. So probably this looks okay as well. What else can look better? Purple, whatever color you want to choose. Similarly, you can go around the sleeves as well. Like a sleeve can have a different material. I'm going to call it a material, which is matte teddy sleeves. Make it flat, bring it out. Also assign the same thing here, and change the color to probably some different color. And you see that the purple is assigned to the left one. There's a right also, the right sleeve geo. So we're gonna give the same material to that guy, right sleeve. So we have we have the colors to that as well. Now maybe change something else, change the box hat, change the hat maybe, give it a new material. This is just creating material and assigning them. So I'm gonna matte hat. Now, don't have to drag it out here. You can directly probably assign this teddy texture already, and change the color, like maybe some whatever lemon, neon, whatever. So feel free to add your own modifications. And all right, we are done for today. You can use option picker and choose different textures, like different colors, um, and like give it like a one color here, second color here, third color, this one, fourth here, and give it like an ability to change the colors to the user. Maybe if you screen tap, the color would change like that. that can be done as well. So yeah, we'll take up the questions now. Yep, 15 minutes left.
Uh, Guys, I think there is some kind of technical glitch from our mentor, so he'll be joining us within few seconds. So till the time, if you have any doubts, you can please pin them down in the comments.
Naveen, you had dropped.
Yeah, what happened? I thought like, where am I? I look at the YouTube link, like somebody hijacked my YouTube link.
Naveen, you had dropped.
Yeah, what happened? I thought like, where am I? I look at the YouTube link, like somebody hijacked my YouTube link.
Naveen, you had dropped.
Can am I audible now? That's good.
Yes, you are.
Okay. Uh, was I gone for like too long, or just dropped?
No, no, just dropped like 1 minute.
Okay. Okay. Cool. All right. We are done with today's session, and we are ready to take up some questions. Feel free. Also, can you send me the link? The I think you probably have, but I dropped, so I can't see this. The
Link to the document.
Yeah.
Yeah, sharing it.
Shekhar asks a very good question. Shekhar's question is, can we increase the size of the rectangle more than the view part of the camera or more than the width of the thing? So I'm going to close this unrelated to this project. I'm going to open a new project where Shekhar's doubt we're going to clear. But before that, I have to share my screen. So is it visible? I think it should be visible. Um, Blank project right now, nothing added to it. We just imported a blank project, like created a blank project. And to the second question, Shekhar wanted to add a canvas and also wanted that if we add a rectangle, and right now the rectangle comes like 100 pixels and the 100 pixels, and it's a fixed size. And what we usually do is that to make it relative so that it's like kind of fits the it fills the width. But he's asking that if we can increase the more than the viewport, so why not? You can import and you can exchange. You can do whatever you like. But I am not sure how is that useful in terms of usability. Of course, in some cases, that depends on you. So to answer your question, of course, you can do that. But here is an additional information that I want to give with this. So how many people, I don't know how many people are watching right now, but who are not watching, they will miss this very important concept. So let's take an image from the, let's take this image. Okay, I'm going to import this image here, and none. The first thing that I do is that I check the compression settings, none. And Right now, let's not make it that big. Let's just make it fill width and fill height, and the position to 0. If you see that, you can also reposition it, whatever you want to do with the thing, then you can see the position is changing. um, you can also um, keep it 100%, 100%, and also change the scale, like make it bigger, and like you can see the size is changing. It's, it can go view bigger than the viewport, but what you see in the simulator is whatever is there on the focal plane. So going to keep it 1. um, Sandesh, this is Shekhar. This is just an additional information that can help you to make good textures, assign them on a 2D effect. 2D effects are tricky when it comes to like to fitting all size of devices. So take this rectangle, take a material, make it flat, and I'm going to assign this texture. This is 576 cross 1024. No, I don't want that. I'm gonna download a 1024 cross 1024 texture circle. I'm gonna download a circle. Um, let's download a circle which is maybe this one. Okay, so um, I'm trying to import a texture which is a square texture. Okay, and I want to uh, make you feel the differences between the. Don't like that. Looks okay. Okay, so again, not the best thing. Why don't I have any 104 cross 104 textures? This is just to experiment. I would not recommend to use these textures for your live projects. This is just to explain you some things. Okay, finally, we have a texture which is suitable for our example. Um, I'm going to import this, rename this to like a circle. Again, this is 994 cross 992. All right, we're going to make our own texture. You're not dependent on the internet sometimes. Um, we'll just make a texture like a 1024 cross 1024 texture in Photoshop, and then import it in Spark here and see that how that works. All right, this is a background which is transparent. To make it transparent, I'm gonna add probably a circle, a shape which is an ellipse or a circle. Okay, this is a circle properly centered, and this is going to be a 1024 cross 1024 image. There's nothing gonna stop that. Circle image. And I hope it is exported in the Navi section. All right. So now we go here, delete this, add a circle image. Now you can see this is a 1024 cross 1024 image. It is a circle, and any texture that you import in Spark here, always keep them into the 2 to the power something. For an example, 256 cross 256, 512 cross 512, 1024 cross 1024. There are like 2 to the power something, because computer is able to understand them better because of the binary calculations in the logarithmic and 2 to the power. That's how they work. So we kind of try to keep them like that, so that the conversion is always easier. Now this rectangle has this material, and if I try to apply this texture to this guy, this image, do you see what's happening? Do you see that? Is this my original circle? My original circle is a circle. This is not a circle. This is an oval. Now, why is that happening? If I do that to a plane, like if I take a plane and the plane is a square plane, and I'm gonna disable this and give this plane the same material, it doesn't happen with the plane because the plane is a square, right? The plane is a square thing, and my circle is also, dimension is also square. So that's happening with the canvas. Okay, so if that's happening with the canvas, I need to make sure that I fix this. To fix that, I bring this device down. Very important, I bring this device down, take my screen size, divide it by the screen scale. If you divide your screen size with your screen scale, you kind of get a device resolution. And once you have that, what is wrong with these patches? If you have that, I will now unpack it. Basically, I want this ratio of how the things are divided um, into this rectangle. So I want this ratio to work with. So I'm going to take this ratio. How do I get the ratio? I'm going to divide the x by y. I'll get this a number like a 0.4. So this is my, I'm going to take this like a aspect ratio. So this is my ratio of, are you following until here? There's nothing special. So I divided it by the screen scale. I unpacked it and I divided the x by y so that I know that how much my x should shift with the y, because x is like a less number and y is like a more number. So I need to find that ratio, like for how many x I should be relating them to how many y's. Okay, so that I have like a square fitting, with them. So this sender is my aspect ratio that I'm calling it, and I'm gonna make a receiver so that I can utilize it later. Now I will use this in a texture transform patch, which needs two inputs. One is the texture, which is my circle image, and we used this in our previous sessions. It's not new, and we're gonna take the materials texture and diffuse it here. Right now there are no transformations, so no changes. Then there's a 2D transform pack. Time is over. My clock is telling me to go away, but we're gonna complete this and then we'll take this. Right now there are no changes as well. Now what is changing? The scale is changing. If you see, the scale becomes bigger in Y. It should have been like until here, but just became bigger because the screen is bigger than Y. If you see or look at your mobile phones, they are bigger in Y, they are smaller in X, so that is why this happens. So to fix that, what we'll do, we'll take this ratio and we'll pack this ratio with like we'll make it a 2 vector, and we'll say if my x is 1, then my y should be 0.4, because right now it's like y is more and x is less. So what I should do now to balance this, that for every one x I should reduce my y so that I can come down to a balance. So how do I do that? If I take the x1, then I should take that ratio that I divided x by y. For every 1 pixel I will make the y to like about 46%. And then probably I can multiply this number to, like, scale it bigger or something. I always do this maximum. I will always multiply this with a number right now, number one, so no change, and I bring it to the scale. Now you see that that thing has become a circle again. All right. Now you can modify this multiply number to scale it or not scale it, like do whatever you like. But that's a very very important concept, guys. Note it down, probably like take a screenshot or something. This is going to be very 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 useful for you um, throughout this Spark AI development. You start from today, and then okay, this is done. Shekhar, I hope you're clear from it. um, Very quickly, I'm going to take other question. Can we use rectangle on percentage spaces instead of full width and height? I hope I answered your question now. Will iCaric works on Spark? Yeah, that is already answered. Sandesh Ishab Thakur, how to optimize your AR project storage? I am working on my project and added GIF, but when I'm going to publishing for the project says you have size more than 2 MB, not supported for Facebook. That seems incorrect statement. Size more than 2 MB is not supported or not recommended. Read that again. Probably not supported, cannot be there. Or probably share the screenshots with me like later on, because this is just not recommended more than 2 MB, because Facebook users are like sometimes in the rural areas also, and they have less internet speed. So if you make a filter which is like 4 MB, might be like a very harsh thing for somebody who's living in rural areas. Will there be a problem if we use texture compression Spark here? No, there not be a problem. It's just you are not in control of that compression. That's the only thing. So how can you be controlling the control of the anything that you already do it by yourself, rather than a like software to do it for you? Because they can depend on like device to device, and they the textures might appear different from how you want them to appear. So Sparks compressions are best. They're nice. They're super nice. You can use them here. I use a software called Crushy. Um, Crushy. It is also available for Windows and Mac. You can use Crushy, and the Crushy is like I just add texture here, like whatever texture. Like suppose this 366 KB we just made, or I do this 17 KB file, and if I crush it, this will be crushed like 70% smaller, like 4 MB right now, the 4 KB right now. So my this is like 74% it reduced the size. So that's a good compression. This tool doesn't really like change the quality of the thing too much, so it's a good tool that you can also utilize. Okay, I think we are pretty much done for the session. And let me know any questions if you have later on as well. Write them down, but like if you have not asked them now. Um, Askar, over to you. Thank you so much for joining in, guys. Cheers. I've taken like 5 minutes extra today, so next time we'll close it at 7:55. Askar, are you here? Over to you.
Thank you, Naveen, so, for a wonderful session. I hope everyone has learned skeleton animation today. So, guys, if you have any doubts, you can post it on the Facebook group. I will add Naveen. I would request Naveen to join the Facebook group. He can also answer those queries. Other mentors are also available on the Facebook group, so you can ask your queries there as well. So we'll see you next week now. And thank you, Naveen. Thank you, everyone, for joining.
Thank you, guys. Thank you, Asghar. See you in the next session. Bye bye.
Bye.